Okay, so hi there everybody. To continue our video in the exercises in GCD and LCM. So we're now going to have the exercises or answer the exercises in the LCM video presented um, formerly. Or presented before. So we're going to answer that now. First of the questions is, what is the LCM or the least common multiple of 12 and 14? So how to answer this? Just a review. So we have 12 and 14 here. So we're going to prime factorize the 12. 12 is 4 times 3. 4 is 2 times 2, so that's 2 times 2 times 3. To check, this is 6. 6 times 2 is 12. 14 is 2 times 7. We'll put the 7 here. So since it's not common with everything, so you'll see why in a minute. I put it like that. So what we're going to do next is to encircle all the things that we can have. There's something in common because we want the least common multiple. So since the 2 here is common for both of them, only one 2, okay, only one 2. So we're going to encircle both of them at the same time, and then we have it here. So what are we going to do? Again, we're going to put down all the common things. So 2 times 2 times 3 times 7. So the product here is going to be the least common multiple. Okay, the product here is going to be the least common multiple. So multiplying here, so 2 times 2 is 4, 4 times 3 is 12, okay? And then 12 times 7, what will that be? 7, 2 times 7 times 2 is 14. We're going to add that here, and then we'll have 84. So the least common multiple, okay, of 12 and 14 is going to be 84. So we'll write it here. Let's erase this first. Not really. So their LCM is 84. Okay, 84. How do we, if you want to check really, um, so 84 is actually 12 times, I say 7. Let's check. Yeah, 12 times 7 is written here. And yeah, 84 is 14 times, yeah, 14 times 6. 14 times 6. So you want to check 14 times 6 as 624. Yeah, that's pretty much 84. Okay, so that's the least. That is said to be the least common multiple for 12 and 14. Okay, carry on. Carrying on with the next number. The next number is asking us what is the LCM of 36, 9, and 45. 36, 9, and 45. So we're going to do it in the same manner. So we have 36 here, we have 9 and 45. So 36 is 6 times 6. 6 is 2 times 3. So let's rearrange that in canonical form. 2 times 2 times 3 times 3. If you want to check 4, 4 times 3 is 12. 12 times 3 is 36. 9 is 3 times 3, and I'm going to align it here with the 3's so that we won't have any trouble. 45 is 9 times 5. So we know 9 is 3 times 3. So 3 times 3 times 5. If you want to check, so 3 times 5 is 15. 15 times 3 is indeed 45. And we will, you know, and encircle the numbers which are common to all of them, or at least both of them. 3 is common. 3 is common. Nothing else is common. So what are we going to do? Bring down everything. We have 2 times 2 times 3 times 3 times 5. Or if you want, we can encircle everything, just like what we did in the last item. So you can see 1, 2, 3, 4, 5 factors. Multiplying them, 2 times 2 is 4. 4 times 3 is 12. 12 times 3 is 36. What we're going to do is just multiply it by 5. I think it's it's what, 180, but let's check. 15 is going to be 30, and yeah, that's 180 indeed. So the LCM, therefore the LCM of these numbers is 180. So the first number, the least number, which are common as their multiple, is 180. Okay, it's 180. Pretty much big if you want to use the listing method, and it's pretty much tedious to do that. Yeah, so it's much better to follow this method. Number three, okay, for number three, okay, what we have is 5, 40, and 8. So what is the LCM of 5, 40, and 8? As always, let's write them in this form. Let's prime factorize all of them. 5, 40, and 8. 5 is already a prime number, so that's just equal to 5 times 1. We don't need to write that. 40 is 5 times 8. 8 is 2 cubed, so that's 2 times 2 times 2. 8 is also 2 times 2 times 2. Okay, so if you want, if you can see, we have common here in not all of them, but at least two of them. That's pretty good enough. Okay, and I think we have the answer, which is actually the same as one of our numbers. So we have a 5 times 2 times 2 times 2. That's 5, 10. 10 times 2 is 20. 20 times 2 is 40. So therefore, their LCM of these three numbers here is equal to 40, which is pretty much equal to our one of the numbers, 40. Since 40 starts with 40, and 40 is divisible by 8, also divisible by 5. So therefore, that's the answer. 40 then is the answer. Okay, let's proceed to number 4. Okay, so for our fourth number, maybe if I remember it clearly, I wrote this also in the GCF or in the GCD um, video. So I think I overlooked it. But anyways, let's find the LCM of this number as well as the GCD if you want. Okay, as well as the GCD. So let's do this first. 20, 30, and 40. 20 is 2 times 10. 10 is 2 times 5. So let's write it in this way. Maybe I can put it here. 30 is 2 times 15. Okay, 15 is 3 times 5. Okay, if you want, this is 2 times 3, 6. 6 times 5 is um 30. Okay, 6 times 5 is 30. 40 is 2 times 20. 20 is 2 times 10. 10 is 2 times 5, if I'm not mistaken. Okay, so 2 times 2 is 4. 4 times 2 is 8. 8 times 5 is 40. So let's copy and highlight the common numbers. This is common to all of them. These two are common to at least two of them. These two, it should not be aligned with this 3 because this is a different number. And 5 must also be highlighted. So bringing all them down, all the boxes, so we have 2 times 2 times 2 times 3, okay, beware, times 5. So let's do the multiplication. 2 times 2 times 2 is 8. 8 times 3 is 24. Times 5 is 120, right? 10, 20, that's 120. So therefore, the LCM of 20, 30, and 40 is equal to 120. Okay, now how about the GCD? Okay, how about the GCD, the greatest common factor? Okay, it should be a common, okay, a common number for all of them, not only two of them, at least two of them. That should not be like that. It should be with all of them. So if we're going to notice here, what is common with all of them is this 2. Let me put that in black. And this 5. So 2 times 5, let's write this as their GCD. Their GCD is 2 times 5, which is equal to 10. So their GCD is equal to 10. So as you can see, the greatest common factor which can divide 10 or um, 20, 30, and 40 respectively is 10. So there's no other number that can do that. Okay, that can do that. That's the greatest actually. There's none anymore. Okay, so that's for number 4. I answered the LCM and I answered the GCD because I have an error in the papers or in the video that I sent you, that I presented. Let's go to the last item for number 5 for this video. Okay, so for number 5, what do we have here? 8, 12, and 16. So what is the least common multiple of 8, 12, and 16? So let's write it down. 8, 12, 16. Factorize, prime factorize 2 times 2 times 2. 12 is, we know this as 2 times 2 times 3 because this is 4 times 3. 16 as 2 times 2 times 2 times 2. Actually, this is 2 raised to 4. Okay, so we'll get all the common factors first. So these all twos are common. These all twos are common. We have at least two twos which are common. 3 is separated, and this other 2 is, well, out of the line. So let's write them all down. So we have 2 times 2 times 2 times 2. There's 4 boxes of 2's times 3. So in short, this is 16 times 3. So we got 16 times 3. So 3, 18. So 48, right? 48. So therefore, their LCM is equal to 48. Okay, so it's equal to 48. Okay, so as you can see, this is pretty much faster than the listing method. Pretty much easier. You just need to don't forget the algorithm followed here, the procedure, the step-by-step solution. And then yeah, you're good to go for LCM and GCD. So thank you very much for watching. I hope you would like and subscribe. Okay, see ya.